ladies and gentlemen.
So let's model with nonlinear equations. Specifically, we're going to model with exponential functions. So our first question is kind of like what part of the equation am I talking about? So if we look at it, it says the growth of a certain bacteria can be modeled by n of t, which equals 280 times 3 to the power of t, where n of t represents the number of bacteria after t minutes. What does the 280 represent in the formula? So a lot of standardized tests sometimes will throw at you, like, what does this part of this formula equation mean in context, instead of asking you to do anything specifically with it. So we've kind of talked about this style of equation before. This is a exponential a times b to the x. So the b, if you recall, is the growth factor. It is the number you're multiplying by each time. So in this case, that's not what we're talking about, but it would be that 3 represents the bacteria is tripling every minute, which is very scary to think about. The a, however, which is what we do have, this 280, represents the initial number. So the 280 means we had 280 bacteria at the start. So not a question of asking us to do math, but kind of interpret what the structure of this is actually talking about. So with that comes, what are these structures? What does it actually mean is going on, especially with exponential growth and decay? So most exponential growth and decay is going to look like this, which looks very scary. It is really no numbers except for the 1. So what does each part really mean? Well, the a sub 0 is your initial or starting amount. R is the rate of increase or decrease as a decimal. So if it's 5%, you're going to put a 5 there. You're going to put a 0.05. T would typically be years, but it could be anything. It could be weeks, it could be days, it could be hours. It really could be anything. It'll be defined in the problem. A of t is the amount of whatever we're talking about after t years. N is the number of time per unit of time that this growth or decay occurs. So if we're talking about compounding money in a bank account, well, the rate is typically defined for a year. So the growth rate would be per year, but it gets compounded monthly. So that N in the formula would be a 12. So there could be a little bit of weirdness there depending on the circumstance. But if your rate and your unit of time are both in accordance with each other, if they're both talking about years, or if they're both talking about months or days, typically you don't have to worry about that N value. And this 1 plus or minus this R refers to your growth or your decay. If you multiply repeatedly by a number that is greater than 1, you are growing. And if you are repeatedly multiplying by a number that is between 0 and 1, you are decaying. So that is why the 1 plus R is the growth factor, and 1 minus R would be the decay factor. Whew, that's a lot. But it'll help you when writing an equation or kind of interpreting equations like we did in question 1. So question 2 is the population of Georgetown is decreasing exponentially. So we're going to use this style of equation to model at a rate of 5.3% per year. If Georgetown has a current population of 9,000 people, what will the population be 14 years from now? We need to round to the nearest person. So we're going to set up the equation we're going to use here, and then I'll pull up a calculator and we can actually evaluate it. So first things first, current population, that is our initial amount. We have this 9,000. And since we're dealing with population in terms of time, let's use a P of T. So 9,000. we are decaying. So we're doing 1 minus our rate, which would be 0.053 to the power of t. And we want to figure this for 14. So we are going to essentially replace this t here with, oh, I missed again, with 14. So 9,000 parentheses 1 minus 0.053 to the power of 14, and we get 4,198.96. We're going to round that up to 0.9. So 4,199 people. And that's it. So really not bad. It's really just looking at all of these aspects and how do all of them play with each other in terms of an exponential equation. Now, if you're asked to model with a quadratic or anything like that, typically they will give you a model and they won't ask you to make a model. Otherwise, you'll have to use regression, which we're not going to talk about here. If you have any questions, let me know. Otherwise, I'll see you in the next video.